Okay, let's get started. A few administrative items. First of all, a reminder that problem set 9 is due on Thursday. Several of you have asked about the extra credit that I mentioned in class last week to go with problem set 9. Just a reminder, I don't want to make a lot of rules about the extra credit. The idea is to look at a series of interest rates. I put an example of such a series up on VSpace. The example I put up is average rates for 3-month T-bills. If you want to use a different interest rate series, that's fine. It might be defensible to use a prime rate, for example, if you're considering the opportunity cost of funds for a firm. But just do something reasonable. The idea of the extra credit is to find a particular series of resource prices and to see how much variation in that series can be explained by variation in the interest rate. So I don't want you to do it. There's not a sort of correct answer to this. I'd like you to get some data and play around with it, make some graphs. If you're familiar with regression analysis, that might be an appropriate tool. It's not worth a huge amount of credit. It's mostly meant to be fun. So treat it that way, please. Okay, any questions about the extra credit before we go? Yeah. Economics is an empirical science. If you find a series of resource prices that don't seem to have any relationship to interest rates, that's interesting. So you should document it. Yeah. Yeah, keep it short. It's not meant to be a term paper or some enormous exercise. Okay, so a few graphs, maybe a regression, a little discussion. The main thing to do is to document what you've done. You should make it clear what the data is, where you got it from, and describe what tools you've used to think about this series. And you don't have to do it. It's really meant to be fun rather than a chore. Okay, other questions? Okay. So additional administrative items. We're drawing near the end of the semester. Some of you may have also noticed that. So we'll have one more regular lecture in this class after today. That's Thursday. I propose next week, during next week, to have a discussion section. In addition to the discussions that the TAs will have, I'll have a discussion 1 week from today, this time, this place. That'll just be a review for the midterm. I'm sorry, for the final. So if you can make it for that, that'd be great. Again, you don't have to show up for that, but I'll be here to do some review in preparation for the final. Okay. Questions about that? There are usually questions about finals, but anyway. Okay. The format of the final will be similar to the midterm. It'll be open book, open note. You shouldn't rely on those books or notes too much. We'll distribute problem set 10 on Thursday. That problem set will be analogous to problem set 5, in that it will serve as a review, principally as a review for the final. So you should work carefully through it. We'll grade some of the questions from that problem set. It's also a good bit of study for the final. I will not this time be tremendously literal about taking problems from the problem set and putting them directly on the final. So they'll be closely related to problems that show up there, but I won't be drawing anything exactly from the problem set 10 and sticking it on there. Okay. Any other questions? Oh, well, yes. So the question is whether the final is cumulative. It is. It's of course, an exam covering the entire course. You might reasonably think that we tend to use tools more from the second half of the course than the first, just because that's been more recent. And now that we've got, something that's nice for me in terms of writing lectures or problem sets, is that now that we have mastery of both demand and supply, it's a lot easier to come up with interesting questions. So we should expect to see stuff related to both halves of economics on the final. Okay, other questions? Okay, and then just an aside, I have a job that I would like help with next semester. Part of the job would involve organizing notes and preparing figures for when I teach this course next year. Other stuff would be more related to providing some administrative help, some of which would have to do with research, other with teaching. If you're interested in doing that, shoot me an email. That's something that we could undertake next semester. Okay, all right, any other questions before we forge ahead? Okay, so let's go ahead and get started then. Oh, a couple things I should say. This is a little bit of fun reading. So a couple things that will be up on VSpace as soon as I manage my internet connection. There's a short article written by Dan Sumner, who's a very good applied economist at UC Davis, called, it has a cute title, it's Beconomics. So take a look at that. And then there's just a little article from the New York Times, a couple years old, having to do with conflicts between trees and solar panels that I think might help motivate some of the examples we'll talk about today and next time. All right, so let's get started. My agenda today, what I want to cover is material related to how to deal with externalities. And so we talked about what externalities are. We have thought about at least one way to address them via Pigovian taxation or subsidies. So we're going to work through a careful example today involving positive externalities, and we'll derive some Pigovian taxes. We'll also get to an alternative solution. That's a solution that's associated with Ronald Coase, who's an illustrious economist, still at the University of Chicago. I'm not sure when he joined Chicago. I think he's 101 now, though. He's still active on the Lewis Law School faculty there. Here's something that Coase wrote about a little over 50 years ago. So he says, when economists are prevented from sleeping at night by the roar of jet planes overhead, publicly authorized and perhaps publicly operated, are unable to think or rest in the day because of noise and vibration from passing trains, publicly authorized and perhaps publicly operated, find it difficult to breathe because of the odor from a local sewage farm, publicly authorized, perhaps publicly operated, and are unable to escape because their driveways are blocked by a road obstruction, without any doubt, publicly devised. Their nerves frayed, mental balance is disturbed. They proceed to declaim about the disadvantages of private enterprise and the need for government regulation. So Coase is reacting here to what was a real flurry of interest and excitement in the economics profession in the 50s and 60s after Zafir-Begou. Sorry, what have I done here? After Begou, in their attempts to devise sort of optimal taxes to correct what they regarded as a variety of social ills. And sort of in a somewhat silly way, he's pointing out that a lot of the ills that people might complain about might themselves already be the result of some sort of regulation. So we'll come back to a Coasean approach to dealing with externalities later this lecture. Okay, so let's get started. I want to start with describing a simple problem involving externalities. This is a new example. And this has to do with bees and apples. This is actually a classic example in the economics literature, but it's a nice one for illustrating some of the points you have to make. So the idea is simple. There's an apple orchard owned by an apple grower, a pomologist, I guess we'd call it. And that firm operates the orchard, produces apples, sells them. Next door to the apple orchard, there's a beekeeper. And the beekeeper has a bunch of hives of bees and produces honey. Okay. Now, there's an externality because, of course, bees need to get pollen from plants to make their honey. And the apple orchard is conveniently located next door in this case. The apple orchard, so there's a positive externality there. The more apple trees there are, the easier it is for the honeybees to find sources of pollen. Conversely, apple trees have to be pollinated, and so there's a positive externality for the apple grower associated with the number of beehives next door. Okay, so that's the framework for this simple little example. And I want to tell a story where we have a production function for honey. So H is honey. I'm going to make it a function of two inputs. One is the number of bees. So B is the number of bees. And it's also going to be related, though, to a variable that the beekeeper doesn't control, which is the number of apple trees next door. And that's capital A. Conversely, there's an apple production function. I'm going to make this one really simple. It's going to turn out to be just a function of the number of bees that are available to pollinate the trees. Okay, so that's the setup. Two simple production functions for two producers situated next door to each other. And we've got the story about there being sort of multiple. There's a positive externality going in both directions. Apples, the number of bees increases the number of apples, and the number of apples increases the amount of honey. Okay, so the setup there. Okay, so we're going to work with this little example for the next bit of this lecture, and we're going to ask some sort of pointed questions about this example and work them out in some detail. So the first is this. We're going to figure out what the private level of B is. What's the level of bees that we'd expect to observe if there was just private production by the beekeeper and the apple grower, ignoring the actions of the other. We'll call that the private level. Then we'll characterize the socially efficient level of bees and apples, and we'll do a comparison of those two levels, and then we'll think about ways we'll show that those things are different. It'll turn out, you won't be too surprised, that the private level of provision of bees is going to be lower than the socially optimal level, and then we'll talk about different ways to correct that externality. Okay? And this is a little textbook example, but the methods you're going to use are going to sort of be tools you can use to address a really wide range of externalities. Okay. All right, so the first thing I want to do is think about characterizing the private level of bees. So there's a honey producer. We already talked about this. We described the honey producer's production function. And we're going to think about the honey producer facing a cost of keeping bees. Bees aren't free. There's going to be a cost C associated with each hive that the beekeeper keeps. So that's going to be a quantity little c. And there's going to be a price for honey, P sub h, that the beekeeper can sell the honey for. So the problem facing the beekeeper is going to be to maximize profits from honey production. And so she's going to do this. She's going to maximize P sub h times h minus c times b. Okay, so b is the input she's going to choose. She's going to choose, this is going to be subject to the production function. In particular, we're going to have h equal to, there's the production function there, is equal to the fourth root of b times the square root of a. And here's the sort of trick that produces the externality. She's going to do this. She's going to choose b and h here to solve this thing, taking a as given. Okay, so there's some quantity of apple trees next door that affects her production of honey, but she's just going to take that as given. She doesn't have any control over that. Okay. All right, so is this clear? Yes.
Say that the apple growers choose A and choosing their output, doesn't that depend on the number?
Yeah. So just to make this as simple as possible, I've given the apple producer it's a pretty degenerate problem. So they're going to want to take b as given, and that's going to make it easy. A more realistic example would make it depend on b and some other input the same way that the honey producers do it. Yeah. I don't think making it that simple doesn't do damage to the logic of the externality, I think, but it makes it so I only really have to solve one producer's problem to get the characterization after. Okay. So this is the problem. We can immediately simplify this thing by substituting this production function in for h, and so we can rewrite this problem as maximizing, just like choice of b, the quantity p sub h times the fourth root of b times the square root of a minus cb. So this now is just the revenues for the honey grower. These are its costs. Okay. Again, we're going to take a as given. It's outside the control of the beekeeper. Okay. So we've now got a problem set up so that we can easily solve it. We can take first order conditions here. So there's only one choice variable. What are we going to get for our first order conditions? Okay, we've got v shows up here to begin with, raised to the 1/4. So we'll have 1/4 there. And that'll be a pH. Excellent. Oh, I like how you're doing that in unison. That's nice. So we'll have square root of a, and we'll have b to the minus 3/4. I'll write it that way. And what else am I missing? We can get some harmony going on here. And that's going to have to be equal to 0 at the optimum. Okay, very good. Yes, Scott.
Why can't you sub in square root of b for a?
That is a very good question, and it's critical that we don't do that. The reason is because we're assuming right now that this thing, that we're taking a as given. So, you're observing that a is equal to the square root of b, and if we did the substitution you're suggesting, we can get rid of a here by putting in b, and we're going to do that later to characterize the efficient solution. But if we did that, since the person's choosing b, they no longer be taking a as given. They'd be controlling the amount of apples indirectly. So that's why they have to take as given the quantity of a over in the neighboring field, rather than trying to modify with a choice of b. It's a little artificial in this problem because there's such a direct connection between apple production and bee production. Again, a more realistic example would look more realistic. All right, so let me go ahead and solve this thing. I want to solve this for b. Just rearranging this. Let's see. I've got a b to the 3/4 here. Let me move this over here. So I'll have c times b to the 3/4 equal to 1/4. I'll make this ph over 4 times the square root of a. And now I'm just going to move the c over here. So I'm going to have b raised to the 3/4 equal to ph over 4c times the square root of a. Then raising both sides to the 4/3 gives me just this. So that gets us this expression for b. It's worth pausing here for a moment before we go on to notice a couple things about this. First of all, so this is the private level of b that's going to be provided. How does it depend on honey prices? Well, okay, it's increasing to 4/3 is, positive things. It's going to be increasing in honey prices. This is like an input demand for the honey producer. It's going to be decreasing in the cost of the input b, all as we expect. And here's the sort of critical part. The input b that gets chosen by the honey producer is also going to be strictly increasing in the level of a. So the larger the apple orchard next door, the more honey this person would produce. But because they're taking a as given, there's this externality. All right, is that clear? Maybe I'll do something else here very quickly. We've got this level of b here, and we know that, where did it go? We know that h is equal to this quantity. So if we just take this and substitute it in here, we can draw a supply curve for honey production as a function of p sub h. And I guess what we'll get in that case is a supply curve, an inverse supply curve that looks like h squared Is it h squared? Hold on, that's not what I want. Okay, let me try. There's a supply curve for honey that looks like this. We can get it by substituting b in here, and that'll give me, well, it'll give me just, so I guess this implies that h is equal to, the fourth root of b will be just ph over 4c square root of a all to the 1/3. And so this should be the, and then the inverse of this will be this curve, so it'll be something to the third power as a function of ph. So this is the, did I miss something? Times the square root of, oh yeah, thank you. Okay, very good. I'm not sure who said that. Somebody deserves an extra credit, probably. Scott, by acclamation. Yeah. Okay. Yeah, I'm not sure about everybody. But okay, anyway, so this thing is going to be, the inverse supply curve is going to involve pH raised to the third, and so multiplied by some stuff involving A. So this is an example of the supply curve with one level of A. For a different level of A, higher level of A, we get a supply curve that looks like this. For that, this is all for the beekeeper. Okay. All right, so we've got this. That's very, I'm sorry, not this. We've got this expression for B. That's one equation. The other thing we have is the supply equation. We can go ahead and use the, I'm sorry, not the supply equation here. We've got this plus A equal to square root of B, the supply for apples. We can use this and substitute in here and solve for the private level of B just as a function of prices and get rid of the A. Yes?
Is the entire thing be raised to the 4/3 is about a third of A, or just because the price in the divided by 14 was right?
No, all I did was to move from here to here was to raise both sides to the 4/3.
Oh.
So this is for B, not for H.
Oh, never mind.
Yeah, so no problem. Okay, yeah, so I think this is right. If we multiply by the A here, we can simplify it. And I encourage you to do so, but I'm not going to do it on the board here. All right. Okay, so we've got this thing. That means this implies, of course, that the square root of A is equal to the fourth root of B. And so we can substitute in that into there. That's going to give us a new and improved expression for the private level of provision of B. So in particular, we'll have P sub H over C. And we'll have B to the 1/4 divided by B to the 3/4. And that's going to have to be equal to, I'm sorry, this 4 is going to be equal to C. And this is going to imply solving this 1/4 cancels out. So we're going to get the private level of provision for B equal to PH over 4C, this whole thing squared. Yeah. And so that comes from substituting this fourth root of B into that expression and solving it for B. All right, so what's the private level of provision? What's the private level of provision for B? That's our first question here, and here's an answer. It's BP, depends on the price of honey, depends on the cost of C, and involves this square term. So we're able to substitute out the dependence on A there. Clear? All right, so that's fine. The next thing we want to do is to address the second question. What's the efficient level of B, or what's the optimal level of B? So to tackle that problem, I want to think about what an efficient level would mean here, sort of a way to implement that. And the way I want to think about that is we've got these two fields side by side, one producer producing honey, the other producing apples. One way to think about solving for the efficient solution would be to say, well, suppose there weren't two different owners. Suppose there was one farmer who owned the apple orchard and the beekeeping operation. So that would be an example of achieving efficiency efficiency by integrating. So we have an integrated apple bee operation. The same producer would realize the profits from apples and from bees, and what was formerly an externality would now be internal to the firm that was doing the production. So it would be one direct way to internalize the externality. So you can imagine sort of a mergers and acquisition style solution to the problem of this externality between bees and apples. So that's one way to do it. That's also a way to characterize the efficient solution. So let's imagine the problem facing a single firm making profits from production of both of these goods. So let's go ahead and characterize that problem. Let's see if I can do this here. Yeah, okay, so actually this just says that. So we're going to imagine now the beekeeper is going to purchase the orchard or something like that and solve a new problem. The new problem is going to be to choose A and B. So the beekeeper is no longer taking A as given. The solution to the problem here now, the profits are going to be pH times total honey production, which is, as before, the fourth root of B times the square root of A. So this is revenue from honey, plus revenue from apples. So that'll be PA times A. So that's the total revenue for the integrated producer. And what are the costs that she'll face?